Alrighty, problem number 7 on the study guide, graphing. I like these problems. I think they're fun. But anyways, the first part of the problem, we have two functions to graph. F of x equals 3x cubed, which is kind of hard to see on this video, but you have it on your sheet. And then the second one, the inverse of that, log base 3 of x. We want to graph both of these on this same set of axes. So to do that, hopefully by now you recognize that all of these exponential functions are going to look something like that. So let's get started. The key here is the y-intercept. I'm specifically going to be looking for you to show me where your y-intercept is on this first graph. So 3 to the x, well, to figure out where the y-intercept is, plug in 0 for x. 3 to the 0 is 1. So we're going to have a y-intercept of 1 right there. And then, we could quickly draw in a sketch of what this looks like based on what we know about exponential functions. But if we wanted to, we could get a lot more precise with it, which is typically better to be more precise than not precise. So let's just check a few numbers. At an x value of 1, we plug in x to our function. 3 to the 1 equals 3. So at x equals 1, we're up to 1, 2, 3 already. See how quickly exponential functions grow? At x equals 2, we're at 3 squared, which is 9. So we're already up, like way up off this graph. Like way up there, which is nuts. But that's okay. I'm going to draw this curve in. Now, the key here that I want you to show me, other than that y-intercept at 1 right there, is I want to see your graph getting closer and closer to 0 as x gets negative, but never touching it and never crossing it. Remember, that's our horizontal asymptote. All exponential functions have that horizontal asymptote. It gets super close to it, but it never crosses it. So we're done with that first part, and we're ready for the second part. We want to graph the inverse. Well, remember, inverses are so awesomely related to functions. All you have to do is swap the x and y values, which is equivalent to saying that you're going to flip this graph across that line I just drew in purple, which is y equals x, the diagonal line cutting across your screen. Now, a couple key things to note here. Again, if you think about the y-intercept on our exponential function, well, that's going to become an x-intercept on this function because x and y are swapped. So I get that point right there. Other key thing to note here is that asymptote we were talking about. It was a horizontal asymptote in our exponential function. So since x and y are being swapped, it will become a vertical asymptote in our log function, meaning it's going to run right down the middle right there on the y-axis. So think of it like this way. Over here, as x got negative, our y values got super and super closer to 0, but never got there. So on our inverse, we're going to have the opposite. As y gets negative, our x values are going to get closer and closer to an x value of 0, but they're never going to cross. So we're going to have that vertical asymptote there. Our graph's going to come up, hit our intercept, and then curve off. Notice we're swapping x and y, so if you do find that point right there, we can go ahead and actually use that on our inverse function too. That is the point 1, 2, 3, 0, 3. So that's going to flip to the point, I'm sorry, that's 1, 3. So that's going to give us the point 3, 1 on our inverse function. So 1, 2, 3, 1 is right about there. So we know it's going to cross there and shoot off like that. And we're done with that part. Second part is then to look at this other function, g of x, which is log base 3 of x minus 4 plus 2. This is going to be the same exact graph as that red one, except with these two transformations, that minus 4 and that plus 2. So you just got to ask yourself, what do those transformations do to a function? Well, minus 4 inside the parentheses. If it's inside the parentheses like that, right up next to your x, that is going to be a horizontal translation. You can think about that because it is right up next to an x value, and x is going back and forth in the horizontal direction. So this is the weird one where the subtracting of 4 actually moves our graph to the right 4, but that's okay. All I need to do is think about these key points. I know that x-intercept on that graph right there is supposed to be at the x value 1 with a y value of 0. But this transformation, minus 4 inside the parentheses there, that's going to move everything to the right. So instead of being at 1, it's going to be at 1, 2, 3, 4, 5. Okay, interesting. But notice I said that it's going to move everything over to the right. So it's also going to move that vertical asymptote I had over to the right. So instead of being at 0, now that's going to be at 4. So I'm going to have a vertical asymptote at 4. Last transformation to think of is that plus 2. Adding or subtracting something at the end of your function like that, that's like saying, do this entire function, log base 3 of x minus 4. Then, whatever your y value is, add 2 to it. So it's going to shift everything up 2. So instead of having an x-intercept at 5, 0, like we talked about, it's going to move up 2. So it's going to move up 1, 2, and that's where our x-intercept went. Now we just need to draw in the general shape. We know it can't cross that vertical pink line, so to the left it's going to get super close to it but never cross it, and then to the right it's going to curve off, just like our last one did. Notice that the shape is almost exactly the same as that red function. Well, the shape is exactly the same as that red function, at least it should be. It's just shifted to the right 4 and up 2. Do that and you're done.